You think you chose your computer, your games, your AI tools. But the reality is this. A single company quietly decided what all of them would become, long before you noticed. Every day, hundreds of millions of people play games powered by a single type of technology: GeForce graphics. Inside those machines sits a chip that has shaped digital reality for nearly 3 decades. For almost 30 years, Nvidia's processors have defined what's possible in visual computing. When the company introduced the GeForce 256, it didn't just release a product, it introduced the term graphics processing unit, and in doing so, rewrote the rules of computing. But today, those same chips are no longer just about games. They're fueling something far bigger. The sudden rise of tools like ChatGPT triggered one of the most intense technology conversations in modern history. Investors flooded into artificial intelligence, startups multiplied overnight, and researchers who had waited decades finally saw the world catch up. At the core of these large language models sits Nvidia hardware. After years of investing in AI while competitors hesitated, Nvidia is now benefiting, while other chip makers struggle under geopolitical pressure, trade restrictions, and weakening demand. Yet this success comes with a vulnerability. Almost every Nvidia chip is manufactured by a single company, TSMC, in Taiwan. That dependency ties Nvidia's future to global politics, especially US-China relations. For investors, that risk overshadows everything else. This isn't the first time Nvidia has balanced on uncertainty. Several times in its history, the company came dangerously close to collapse. Each time, founder and CEO Jensen Huang made bets that seemed impossible at the moment. Mistakes were common. Some nearly destroyed the company. In the early years, Nvidia was small, competing against massive corporations while trying to invent technology that didn't yet have a market. But those risks shaped everything that followed. 3 decades later, Nvidia stands among the world's 10 most valuable companies, and Jensen Huang is still leading it. Huang personally delivered one of the first AI supercomputers to OpenAI. Born in Taiwan, raised in the US, and trained as an engineer at Oregon State and Stanford, he co-founded Nvidia in 1993, after late-night conversations at a Denny's diner. The idea was simple but radical. PCs needed specialized acceleration for graphics, something CPUs alone couldn't deliver. At the time, many believed general-purpose CPUs were enough. Nvidia disagreed. Nvidia launched from a small condo in California. Its name combined next version with the Latin word for envy, hoping competitors would one day envy its speed. GPUs became its core business, generating over 80% of revenue. These chips don't replace CPUs, they enhance them, accelerating workloads CPUs struggle with. Most early GPU companies disappeared. Nvidia survived by focusing not just on hardware, but on software ecosystems. This wasn't a chip company, it was an end-to-end computing platform. Gaming became the breakthrough use case. Visual effects, Hollywood rendering, and real-time graphics followed. In 1997, Nvidia designed its first high-performance graphics chip. Crucially, it never manufactured its own silicon. Instead, it became a fabless company, outsourcing production to TSMC, dramatically lowering costs. In 1999, after layoffs and near bankruptcy, Nvidia released the GeForce 256, the first fully programmable GPU. Soon after, Microsoft selected Nvidia to power the original Xbox. That same year, Nvidia went public, but its stock remained flat for years. The real inflection point came in 2006. CUDA changed everything. It transformed GPUs from graphics tools into parallel computing engines, allowing thousands of calculations to run simultaneously instead of one at a time. This architecture turned GPUs into ideal machines for artificial intelligence. For years, Wall Street ignored it. The investment was valued at zero. Then, around 2016, it clicked. AI workloads exploded, and CUDA suddenly became essential. In 2012, a neural network called AlexNet shattered performance records using Nvidia GPUs. That moment is now considered AI's turning point. The same technology used to render lifelike graphics turned out to be perfect for deep learning. Nvidia reorganized the entire company around AI. Every chip, every system, every roadmap. What started as one researcher became a growing AI division powering breakthroughs in medicine, science, and automation. In healthcare, Nvidia-powered systems accelerated genome sequencing from weeks to hours, saving lives. In art, AI-generated installations now cover entire buildings. In crypto, GPUs fueled mining booms and busts, distorting gaming markets and prices. Even as gaming revenue declined, AI demand surged. Tech giants filled data centers with Nvidia. A100 systems, sold not individually, but in clusters costing nearly $200,000 per unit. These systems trained models like ChatGPT. Computing power became Silicon Valley's new currency. Export bans cut Nvidia off from parts of China. The company redesigned products to comply. Meanwhile, dependence on TSMC remains a global risk, one shared by nearly every major chipmaker. The U.S. CHIPS Act and new factories in Arizona aim to reduce that vulnerability. But competition is rising. Customers are becoming rivals. Cloud companies design their own chips. Automakers do the same. Huang sees this as inevitable. Demand for compute is growing faster than ever. Nvidia's technology now powers robots, warehouses, self-driving cars, simulations, and digital twins. Former failures, like Tegra, found new life in robotics and autonomous systems. RTX reinvented graphics using AI-based ray tracing. And now, Nvidia is betting on the Omniverse, a unified platform combining graphics, physics, AI, and simulation. Hundreds of companies are already testing it. For Nvidia, it's not a side project. It's the next container for everything they've built. Nvidia didn't just ride the AI boom. It built the infrastructure decades before the world understood why it mattered. And whether the future belongs to humans, machines, or something in between, its foundation is already in place.